Okay, so we're going to be looking at limits to infinity and horizontal asymptote lines. The first thing I would direct you to is the summary of rules from class. Okay, so we need to know things like when it's bottom heavy, right? Meaning a higher degree in the denominator, that always goes to 0, right? Or we can have the degrees the same, or it could be top heavy, right? Where we have no horizontal asymptote line and the limit to the infinity as x approaches infinity is either positive or negative infinity. Okay, so I would ask you to familiarize yourself with these rules before coming over and attempting this handout. So let me do a few of them with you together and then leave the rest for you to try while you pause the video. Okay, so top function, top heavy or bottom heavy, right? And the other way to think of it, remember our cookie concept. If the number of cookies grows faster than the number of people, right, we get lots and lots of cookie, right? But what if that bottom function, okay, the bottom function, the number of people is growing faster than the number of cookies, okay? Whenever that happens, this is bottom heavy, limit goes to 0, wouldn't matter if x approached at negative infinity, therefore there's a horizontal asymptote line for this function at y equals 0. Make sure you write out the full equation. Okay, degrees are the same here. Okay, so remember 7x would get left in the dust of 4x squared. So 7x I can even call insignificant. So we did the rich man's rule where we said, okay, $1, that's insignificant when x is big, right? Even 7x is insignificant, right? So you can see how this reduces down. The degrees are the same. This reduces down to a limit of 2. Same if x were approaching negative infinity. Another way to think of this, if you are thinking about the cookie concept, right? The number of, there's always 4 cookies for every 2 people, and that ratio stays consistent over time, okay? So even though the number of cookies and the number of people are growing, they are growing at exactly the same rate, the same ratio. There's always 4 cookies for every 2 people. So everyone always gets 2 cookies all the way across time. Okay, letter F, right? We've decided, oh my gosh, it's got trig, panic, right? We see trig. What we have to remember is that these have values between positive and -1, right? They might have a value like a half, right? So the biggest value that both of these could be would be 1. Okay, so if we use the rich man's rule, we don't care about such a small, insignificant value, right? We can cross these out and say they don't even matter. And we have the degrees being the same. So, and again, same whether we were approaching positive infinity or negative infinity. And our horizontal asymptote would be here. Okay, now number of cookies, right? The numerator is growing faster than the denominator, right? That means we get more cookie. We get as much cookie as we could ever possibly want. Now, if I took the rich man's rule and said, these don't count, and I reduced this down to x, and I said, what is the limit of x, right? Just the function x, that's what that would reduce to. Well, that would be positive infinity if x approaches positive infinity. But if x was approaching negative infinity, right? What happens as x approaches negative infinity? This would go to negative infinity. Okay, and so this would be a case where there is no horizontal asymptote. I'm just going to write HA. Okay. These functions, these polynomials, as soon as you see the polynomials, you should immediately say, again, no horizontal asymptote line. As soon as you see that, right? Polynomials never have them. None of the trig functions ever have them. We're seeing them in only our rational functions. And we did also see it in our exponential function, right? Y equals 2 to the x had one, but, you know, never in polynomials, never in trig. Okay, so this requires you, you did a lot of these in high school. This requires you to know what the end behavior of a cubic looks like, right? And I hope you know that a cubic, right, where there's positive leading coefficient, does something like this. So as x gets large in the positive direction, we approach positive infinity. As x gets large in the negative direction, which I should say, or as x approaches negative infinity, this arrow is going down to negative infinity. Okay, so you think about what it means to have a parabola with a negative here. And let's have you try, let me see, while we're doing them together, I'm going to do one more with you. Because sometimes students, this looks a little different because the 7 is off to the side. Remember that this 10 divided by many people, I have 10 cookies, many people showing up to eat the cookies, right? This goes to 0. This kind of really reminds me of the bowling example, right? Where we have some constant over x plus something, okay? And this, so this part goes to 0. I'm left with a 7 here, a 7 here, therefore y equals 7. Okay, so pause the video and you try the rest of these. Okay, if you're back, I hope you remember that a parabola with a negative leading coefficient opens like that, right? Meaning as x approaches positive infinity, the function actually goes to negative infinity. Those arrows are going down. And as x approaches negative infinity, arrows are going down there as well. And so, of course, this is part of the, I'm putting quotation marks, the no horizontal asymptote line. Okay, over here, degrees are the same. Be kind of careful. Like, I didn't organize this in standard form, right? Usually we put the highest power first, but that numerator is written not in standard form. Degrees are the same, meaning that the limit is the ratio of the leading coefficients. Doesn't matter if we approach negative infinity or positive infinity. Look how often these answers are the same in both these columns. That's what I said, 99.9% of the time, it's the same for either one. Okay. Next one is bottom heavy, right? Degree in the denominator is greater than the degree in the numerator. So that's 0. Y equals 0. So everything bottom heavy, always 0. Well, top heavy, right? As soon as I see top heavy, no horizontal asymptote line. And this acts just like the one that I did with you, right? If I threw these away and reduce this down, this would reduce down to just x, right? Well, as x approaches infinity, then x approaches infinity. As x approaches negative infinity, that value of x would approach negative infinity. Okay, and then last example, 1 divided by something huge, right? All these bottom heavy things go to 0, but then if there's some other number, oh, that's a 0. If there's some other number there, then that's what's left, right? Just that fraction goes to 0, leaving me with the negative 10. And then my horizontal asymptote line, y equals negative 10.